Good morning to one and all. Before we get started, I like to express my sincere appreciation to all who have marked their presence today. Patience help us to unite, and the energy we create is what allows us to achieve our individuals as well as the group goals. We have joined here for the short-term training program, IoT-based manufacturing and design challenges and opportunity. So this STTP will definitely enrich all of us to upgrade our knowledge on the IoT, Internet of Things, Industry 4.0, smart design and smart manufacturing, 3D printing, machine learning, deep learning, big data, data analytics, virtual reality, and augmented reality. So first, I like to welcome our manager, Monsignor Dr. Cherian Kanjarakompil, who is the man behind this successful institution. Welcome, Father.
Okay.
Next, I like to welcome our beloved director, Reverend Father Paul Nedumberth, who has always been a guiding light for this institution. Welcome, Father. Next, I like to welcome our director, KK Rajan, our beloved principal, who is leading this institution to greater heights through his great leadership skills. Welcome, sir. Next, I like to extend my heartily welcome to our beloved chief guest, my mentor, and my well-wisher, Dr. Somashay, sir, associate professor from IIT Madras. Welcome,
Thank you
sir.
so much. Thank you very much. Thank you so much.
Next, I like to welcome our beloved Vice Principal, Professor Somi P. Matthew. Welcome, sir. Next, I like to welcome all my HODs, Deans, my dear fellow colleague members, participants to these STTP programs. Last but not least, I like to extend two of the main person or the pillars of this STP, Dr. A. Murugaraj, the HOD, Robotics and Automation, Sri Ramakrishna Engineering College. Welcome, sir. Next, I like to welcome Dr. Sriram K. Vasudevan, the assistant professor from Amrita Institute. Welcome you, sir. So on behalf of all the Vishijyoti family, I extend each and every one of you welcome to this 1 week STTP on IoT-based manufacturing and design challenges and opportunity. Once again, welcome you one and all. Thank you.
Thank you, sir. Let me welcome Reverend Father Dr. Cherian Kanjarakompil, Manager, Vishijyoti College of Engineering and Technology, for the presidential address.
Friends who are watching and following me on the line, I'm happy to be here to inaugurate the STP program for the Mechanical Engineering Department, IoT-based manufacturing and design challenges and opportunity. When I heard first about the Internet of Things, I was wondering what this new thing is. Come to so things is we say the so many fields, already the welcoming department head has already said that we are getting into this new medium, and with a big long program of training. And I am sure this would help us to understand what the thing is, and then to go deep into the Internet of Things, which affects every walk of life, every sphere of our life today. And I wish all the participants all the best and understanding and in-depth knowledge about the things that to discuss today. Eminent guests on the list of participants and institutions from around the country. And all of you, I wish all the best and God's blessings. And with these words, I inaugurate this session. Thank you.
Thank you, Father. Now, we would like to welcome Reverend Father Paul Nedumbrath, Director, Vishwajyoti College of Engineering, for his felicitation.
Respected Manager of the College, Reverend Monsignor Dr. Chiriyan Kanjarakumbil, respected Chief Guest, Dr. Somashekhar, Associate Professor of IIT Madras, respected Principal, Dr. K.K. Rajan, Head of the Department, Dr. K. Shanmukesh, Coordinators, Mr. Arun K. Arun Raphael, the members of the faculty and heads of the departments of the college, and my dear participants. It is indeed a pleasure to address you in the fine morning, because the Department of Mechanical Engineering has arranged a week-long academic program for brainstorming the students and faculty as well. I hope this IoT-based manufacturing and design challenges and opportunity webinar will help the participants to upgrade their knowledge in the field. And VJCET is always happy to promote such endeavors. And we would like to felicitate this program. Wish you all the best. Let the participants get maximum benefit out of this program. Thank you very much.
Thank you, Father. Next, we would like to welcome our beloved Principal, Dr. K.K. Rajan, sir, for the felicitation.
Sir, your mic is mute.
Manager of the college, hello. Hello.
Yes, sir.
Shanmukesh, are you able to hear me?
Yes, sir. Yes, sir. It's clear.
Okay. Respected manager of the college, Monsignor Kanjarakumbil, director of the college, Father Paul Nedumbrath, of the day, Dr. Somashekhar S. Hermath, head of the Department of Mechanical Engineering, Sri Shanmukesh, Sri Arun Raphael, and other delegates, heads of the department, and other dignitaries who are participating in this function today. It's a great pleasure for me to note that the Department of Mechanical Engineering is organizing a Sttp, and that too an IICT sponsored one, on the topic IoT-based design and manufacturing challenges and opportunities. This is a very relevant and very modern topic, and I appreciate the decision taken by Mechanical Engineering Department of Vishwajyoti College of Engineering in selecting a topic of most modern topic for their Sttp. Secondly, I am very glad to note that we have an eminent as the chief guest for inauguration of this program, Dr. Somashekhar S. Hermath, Associate Professor, Mechanical Engineering Department, IIT Madras. On behalf of the college, once again, sir, Dr. Somashekar sir, I extend a warm welcome to you.
Thank you very much, sir. Namaste, sir. Namaste. Thank you. Thank you,
Namaste.
sir.
Thank you. And this topic, IoT-based design and manufacturing. See, design and manufacturing, whatever be the thing, ultimate goal should be in the design and manufacturing should be economically it should be at the lower cost, or you have to bring down the price of the product. Second, the quality has to go up and the safety has to be enhanced. So I am sure this IoT-based manufacturing or IoT-based design and manufacturing will be able to enhance safety and improve the quality, and also it will be more economical. That should be the approach. And the challenges and opportunities when we want to achieve these things, there will be many challenges. And for the youngsters or the R&D personnel or the faculty members and students, there will be many opportunities. And opportunities when we consider, I am sure the students who are going out of and passing out young mechanical engineers, not only mechanical, all the engineers will have a lot of opportunities going to come in this area. So my humble request to the organizers and the participants, or all the faculty members who are who are attending this program today, sir, you have to see that your students, whichever be the institute, whichever be the college, whatever you are learning from here from this Sttp for 1 week, the benefit should go to the students also. So I request not only Vishnudip College of Engineering and Technology, all colleges to arrange some 1 hour or 2 hour program, so that the whatever you have learned today has to be finally go to the students, and students should get an opportunity to understand what is happening, and the study materials which you are getting today has to be shared so that they will be able to read it, understand it, and they will be industry ready, and they will be able to use all opportunities which is there in this particular field. With these few words, I like to conclude, and I also wish all the success and a best 1 week, a very fruitful week ahead. And I am sure you are going to enjoy this new topic. And Shanmugesh and Arun Rafael has taken all effort to make it very, what you call, technically very useful, as well as the speakers are very eminent. And I wish a grand this 1 week Sttp, and I felicitate all the faculty members and other directors participating in this function. Thank you very much.
Thank you, sir.
Thank you, sir. It's a great pleasure to welcome Dr. Somashekar S. Hemant, Associate Professor, Mechanical Engineering Department, IIT Madras, for the inauguration and the inaugural address. Sir, please.
Respected Father, Dr. Charan, Principal K.K. Rajan, Director Sir, and other dignitaries, Arun, Murugaraj, Sriram Vasudevan, and my beloved Dr. Shanmugesh. Very good morning to one and all. I do welcome you all for this 6 days AICT sponsored short-term training program on IoT-based manufacturing and design challenges and opportunities, organized by my dearest friend, Dr. Shanmugesh, and his team of Department of Mechanical Engineering, Vishwajyoti College of Engineering and Technology. I'm so happy to be associated with the Vishwajyoti College of Engineering and Technology, not only today. I'm having a close relationship with Dr. Shanmugesh when he was doing his PhD program at NIT Tirchi, and also faculty colleague, Mr. Arvind S. of this institute is currently working with me as a PhD scholar, and also I have delivered a talk physically in a previous years in this college. Faculty friends and staffs of Vishwajyoti College of Engineering and Technology are organizing various types of FDP, seminar, conferences to bring various personalities from reputed institution to introduce to the various participants. I am so grateful to be here today and extending my sincere thanks to the organizer, basically Dr. Shanmugesh, for inviting me for this wonderful Sttp focused area on smart manufacturing, which is the need of our today. I will share with you today my thoughts on smart manufacturing, which is the paradigm shift from static to dynamic, customer-oriented, versatile manufacturing, which is used to connect the people, connect the machines, connect the material handling and storage devices, and also connect to the various outside world factories. IoT-based engineering is playing a major role in manufacturing and is changing our lifestyle. As Principal Sir told correctly, currently 9 billion devices are connected to the internet, and this number is expected to grow to 50 billion devices to reaching 1 trillion devices by 2025. The expected economic impact is $2.7 trillion to $6.2 trillion annually by 2025. For this, we have, as a faculty, we have to concentrate more on the hardcore manufacturing engineering, where the IoT is used effectively and efficiently to produce a goods with economically, as Principal Sir told. Okay. Now, what we are doing is now in the today's whole week, we are learning how the conventional machining shift is changing to the Mukesh,
Yes, sir.
some internet connectivity issues.
Okay.
No,
Yes, sir. Continue, sir.
this is whether from my side or whole it is disconnected.
I think from your side, sir.
Okay, sorry, extremely sorry. Okay, that's why I'm telling you. In between, I'll follow up you whether I'm connected to you all. Okay. Okay.
Okay.
Now we stop this very brief inaugural address, and I'm extending sincere thanks to the organizer for inviting me for this Sttp. See you very shortly for my detailed talk after this. Correct, Shanmugesh? Okay.
Yes, sir.
Sarve jana sukhino bhavantu. Jai Hind. Thank you.
Thank you, sir.
Yeah. Yeah. Now
Thank
my
you,
talk
sir.
will start afterward. Correct, Arun?
Yes, sir. After the vote of thanks, we can start.
Yeah. Okay. Okay. Tell me when I start.
Thank you,
Okay?
sir. Thank you. Thank you, sir. Thank you for your inaugural address, sir. Thank you. Let me invite Mr. Arun Rafael for the vote of thanks.
Thank you, sir. Good morning, all. I'm very happy and privileged to propose the vote of thanks on this special day. On behalf of Mechanical Engineering Department, the Sttp College of Engineering and Technology, I extend a very happy gratitude to our chief guest, Dr. Somshegaran sir, from IIT Madras, for kindly accepting our invitation and for officially inaugurating the session. Thank you, sir. I would like to express our hearty thanks to our respected manager, Monsignor Dr. Chirian Kanyakumbil, for the presidential address and his blessings. Thank you, Father. We are extremely thankful to our director, Reverend Father Paul Nadambarata, for his message and blessing. Thank you, Father. I extend our sincere gratitude to our principal, Dr. K.K. Rajan sir, for his guidance and constant support to organize this training program. Thank you, sir. I also thank Dr. Shanmugesh sir Professor and Head, Mechanical Engineering Department, and Mr. Arun K, Assistant Professor, Mechanical Engineering Department, who are the coordinators of this training program, for their great effort in organizing this Sttp. I would like to thank all the fellow faculty members of BJCET for their constant support for organizing this event. Finally, I would like to thank all the participants and speakers for accepting our invitation for this 1 week Sttp. Thank you all.
Thank you.
Thank you, sir. Thank you for your welcome address.
Arun sir, can we start?
Yeah, I will share my slides now. Shall we start now?
1 second, sir. 1 second.
Yeah. You tell me now when you want, I will start.
Dr. Somasegaras Hiramat currently serves as Associate Professor in Manufacturing Engineering section of Department of Mechanical Engineering, IIT Madras. To his credit, he has 2 patents, published 56 research papers in reputed journals, and 130 papers in international conference. He has authored many textbooks and book chapters. Dr. Somasegaras is recognized and honored with many awards such as Innovative Student Project Award 2005 from INAE New Delhi, Professor K. Armugan National Award, Certificate of Achievement for Guiding Best MS Thesis from INAE, etc. His areas of research include mechatronic system design, robotics, finite element analysis, micro machining, advanced machining process, etc. Thank you, sir.
So let me invite
Shanmugesh?
Dr. Somashekhar sir for the function. Over to you, sir.
Yeah, Dr. Shanmugesh, I will share my slide now. You'll
Yes,
see
sir.
now whether it is visible or not all. Okay.
Sure, sir.
Now you'll see Shanmugesh
Yes, sir.
completely
Fine, sir.
visible.
Fine, sir. Fine, sir.
Yeah. Shall we start now?
Yes, sir.
Okay. Very good morning, faculty friends. Today I want to deliver on smart manufacturing and research opportunities. The glimpse of presentation is as follows. Let us begin very quickly. Our state-of-the-art laboratory, precision engineering and instrumentation laboratory. Then we'll move on to the digital age or a digital era and its impact on globalization. Then we'll discuss some of the visions implementing the industry 4.0 and how to face the challenges and international efforts and projects and future research perspectives and technology roadmap. Finally, ended with technology roadmap, and finally, I'll conclude my talk. Now, state-of-the-art laboratory, if you see our laboratory, it is a precision engineering and instrumentation laboratory. It is an interdisciplinary laboratory. Mukesh, slide more. Hello, Rajan,
Yes, yes, sir.
but slides are not moving.
Slides are not the state of
Yeah.
the art laboratory. Only one
Yeah,
sentence.
that's what I'm telling. It is not moving. Even though I don't know. Now it is
It
okay.
is coming, some delay.
Yes, sir.
Yeah,
It's okay, sir.
delay in the this thing, I think. Okay, sorry. I am belonging to Precision Engineering and Instrumentation Laboratory. It is a interdisciplinary lab in mechanical engineering. It includes the research scholars belonging to different disciplines of engineering, like electrical and electronics engineers, computer science, IT engineers, and many more. Because it is an interdisciplinary lab, where we are working on the different aspects. We are focusing areas are like this, 5 major thrust areas are there. control engineering, mechatronics, robotics, precision manufacturing, and hydraulics and pneumatics. Under each heading, we are working in the different substreams. Then our research group, they are working on design and development of sophisticated instrumented experimental setup for micro and nano manufacturing, which are used to generate the various features like a micro holes, micro channels, micro textures. And another research group is working on design, development, and analysis of fluid power system components like a EHA, EHSV, high pressure and low pressure regulators for space application. One more research work group is working on the robotic system, the path planning, control, and dynamics. All these objectives are achieved through our dedicated scholars. 1 minute. Only 1 minute, friends, only 1 minute. Sorry for the disturbance. All these objectives in the different domains we are achieving through the various research scholars working on the different domains. As of now, 11 PhD scholars are worked in the all control engineering, fluid power systems, micro machining, and robotics. Also, currently many research scholars are working in these areas. These are the MS scholars who finished their master degree on the different areas of my research work. This will show you the glimpse of facilities available in our PIL laboratory. All you will see, friends, all are the tailor-made setups designed to suit our requirement for various machining operation like a micro EDM, micro ECSM, extrude honing process, hydraulic hybrid systems, the micro pump for drug delivery systems, hydrostatic steering system, hydraulic hybrids, and much more. Also, we are developing the robots for our research work on the path planning and control. This is self-guided vehicle and parallel manipulator for the underwater application, SMA actuation, parallel mechanisms, and multi-robot systems for the obstacle avoidance using the new artificial neural network technique, deep learning embedded in the path planning and control. Now, this is one of the important facility available in laboratory, the workspace calibration, the furrow laser tracker, which is used to calibrate the dynamic characteristics and errors in the robotic system. All ISO parameter, what I have mentioned here, are possible to measure in our laboratory. Then these are the some of the books published on the thrust areas like a modeling and simulation of the electro-hydraulic servo valve for space application. This is the generation of nanoparticles for the application suitability for all. And this is a surface modification using our non-conventional machining process for bacterial adhesion study. And some of the latest papers are published in this book. Now, why I'm showing all these things, friend, is the IIT Madras is providing the lot of opportunities to work in the different domains as a regular scholar, direct PhD scholar, interdisciplinary scholars, external, MS by research, and many more. And also the generous scholarship is available, unmatched MDNs, the greater career opportunities are there. Update the technology and innovation research, work with our department. Online applications always open at February for July admission, October for January admissions. Now let us very quickly move on to our journey from known to unknown. As we know, as Principal Sir told rightly, the manufacturing of product and process is moving on the product cycle, correct? It is moving on the product cycle. What is this? As we know, the activities involved in design and manufacturing. And one more is there very important, product life cycle, meaning this is also very important, which will go along with the product cycle because it will show us the survival of the product in the market from its introduction until death. Already we know that conventionally the product cycle will follows with the customers and market. It is a beginning, and then from this you have to visualize the product concept. Then you will prepare the drafting all the components using the design engineering. Once this drafting is ready, then we are going for the process planning, which will give you the detailed analysis of manufacturing system, available facilities. If facilities are not available to manufacture all the component, what we are doing, ordering for the new equipment and tooling, then production will start. Keep in mind that the scheduling of the component is very, very important to meet the customer's requirement in time. Otherwise, he may change over to the new product. Then also you'll remember, friends, before reaching the customer, each product should be quality tested. If not meeting the requirement, then it will again follow the recycling loop production until it will satisfy the customers. Now, how to speed up this? Now all these activities are automated with CAD/CAM technology and adapting the automated material handling system, automated storage devices, automated inspection, and many more. Correct? In Industry 4.0 and 4.3, whatever you will call, basically it is a FMS, meaning all are internally connected in the Industry 3.0. Here, very minimal handling by the workers. Then to achieve this, what we are doing? We are going for the automation is a main role in the Industry 4.0, where we are using the computer networks and advanced machine tools like robots, smart manufacturing. This is one of the important key element in the production system. Correct? So there is a tremendous development taking place in industry revolution. Then let us will see the paradigm shift in the manufacturing, conventional manufacturing. Let us will see how the manufacturing revolution is taking place very quickly. Now we'll see, friends, here I have shown you the first generation, 18th century, what I will call that time Industry 1.0. Now all these numbers are given after reaching the 4.0. Now in Industry 1.0 in 18th century, the mechanical production equipment powered by the steam, because that time steam and water is only available, friends. Then in the second phase, if you see in the second phase, the Industry 2.0, mass production assemblies requiring the labor and electrical energies arrived. Here telecommunication lines are used to control the various production processes in Industry 2.0. The third generation you will see in the 20th century, what we will call the automated production using the electronics, computers, and PLC. Here you will see the nuclear power is also arrived in the market along with the electrical and powerful computers and softwares are available to speed up the manufacturing activities in Industry 3.0. And later in Industry 4.0, it is a one step ahead of this. Here in the 3.0, internally all things are connected. In Industry 4.0, all the devices internally connected, as well as you have to monitor and control through the external world. That is the beauty here. Here in Industry 4.0, all are intelligent production system incorporating with IoT and a cloud technology and big data analytics are embedded in the manufacturing system. Some of the futures, as I have told you, the Internet of Things, cyber physical systems, networks, and artificial intelligence, and the additive manufacturing technologies to speed up the design and development process is some of the futures in Industry 4.0. We'll see now the Industry 4.0, as I have told you, this is a Klaus Schwab coined this term in the 2016 World Economic Forum in Davos. Industry 4.0 is a German strategic initiative to address the global and dynamic market. So it is one of the revolutionary approach in manufacturing and its economic rewards are immense. So some of the economic rewards, direct benefits, what you are seeing in the Industry 4.0 are improved productivity and the output, the enhanced customization for flexible manufacturing, improved worker safety and output, and access the data across the supply chain for better decision making. Online control is possible in the Industry 4.0. The main theme of the Industry 4.0 is push the global manufacturer to new level of optimization and productivity network. Customer will also enjoy the new strategy for their own customized products. So if you'll see now very quickly, the Industry 3.0 to Industry 4.0, what is going on? Here, you see this is a centralized control here in Industry 3.0. An IT-based system it is, meaning this IT system I am using, automating only one machine or a process inside the factory it is. Then connectivity inside the factory, as I have told you, flexibility, largely it is a batch runs here. Batch run, mass production is allowed in the Industry 3.0. The other hand, if you'll see in the 4.0, the distributed intelligence and control. The IT system here is used for automating the complex tasks across the machines, across the workers, across the factories. All are connected internally as well as externally in the Industry 4.0. Also, as I have told you, connectivity across the supply chain, flexibility here, it is a just-in-time manufacturing here. Even a single product is addressing in 4.0. But in Industry 3.0, we are addressing the group-wise. So, plus, here you'll remember, friends, more and more sensor actuator integration is there, along with accessing the large data collected through the machine tools and all for better decisions. Plus, remote access to factory and machines through the smartphone. Everything you will control using your palm. Then if you'll see now, in essence, the Industrial Revolution 4.0 is fundamentally transform what we will do, industrial value chain, production value chain, and business models. I will give you quickly the 6 pillar values of Industry 4.0, what we are achieving. Reduction in energy, reduction in defects or a waste reduction, improved productivity, quality, agility benefits, increased uptime, then human interaction ensures the smart decisions through the real-time communications and cooperation with machines, sensors, customers, and so forth. Intermittent production rather than the continuous production. As I have told you, in Industry 4.0, it is a tailor-made production. You have to address single customer also here. Now, if you'll see what product we are interested in the current scenario, we interested in the mechatronic products, which they are differ from the conventional products, in which more information processing. For example, if you see your products like a washing machine, smart TV, smartphone, smart board, rather than the material processing, as you have seen in IC engine and olden days photography. Now entirely changed. Information processing is more in the mechatronic product as compared to the conventional products. Some typical product of interest, very quickly I'll show you. You have across these things, you'll see the digital cameras. How many magnifications are there? You'll see. Then high-speed cameras to capture in manufacturing, what we are using, this is the material removed atom by atom in the grinding process or a turning process. How the shearing of material is taking place, we are observing in the high-speed cameras. Also, you are seeing now we are in the era of smartphone to capture the high definition pictures and high definition videos using these type of cameras. What are these, friends? All are mechatronic product, meaning the mechanical processing is very less here, more information processing. Also, we'll see the smart washing machine. What I have shown you here, it is having the smart touch, no buttons as such, smart touch, large number of programs to suit the different clocks. And very high speed it is. Child lock is there, auto stop in catastrophe, large amount of storage space is there. Also, it is what you will call horizontal drum, what you will call Dobby wash it is. So many components are arriving in the market. If you see the smart fridge, it is what I am showing you here. It is a family Samsung family hub American style. It is a Wi-Fi connected. You'll see the whole fridge is Wi-Fi connected, dual purpose, meaning the screen what you are showing acts as a TV, radio, and monitoring the commodity what you are keeping in the fridge, meaning viewing, control everything through your palm. That is what you can call smartphone. Also, you have come across the many products like if you see the domestic and office, dishwashers, air conditioner, laser printers, scanners, heavy duty photocopiers, and if you see the retail component, equipments, automatic labeling, bar coding system, tills in supermarkets, cash register, then ATMs. Also, if you go further, sophisticated instrumental panels in the car, you are sitting inside, you are controlling all the parameters, you are seeing all the speed, everything you are controlling in the panel. Similarly, in the cockpit control, every parameters you will measure in the panels itself. Meaning what is going on, friends? All these devices, sensor and actuator is going to play a major role along with processing. NASA control and also in the sophisticated instrumented operation theaters, all we are using the mechatronic products. Similarly, in the teaching community also, we are using the smart boards, which are used to self-learning. Now, the role of teacher is only the mentor, not as a professor or anything. Meaning, children will learn by themselves by touching the products. Correct? You'll see. Also, these things are enhanced in the external world, like a weather report. Here you will get the multiple windows. There is a multitasking it is. Correct? And also we are using these technologies in the video conferencing. Now, what is going on, friends, now? If you'll see the smart devices are there. What I am showing you here, it is a Sony's device, which are having the self-docking. They will monitor internal status of the battery by themselves. Once the battery is down, they will move towards the charging station. They will charge by themselves. Similarly, solar operated water panels, lawn movers, vacuum cleaners, no need to do anything, friends. All vacuum cleaner, lawn mower, they will do all the function based on the gross growth here, and vacuum cleaner based on the dust and how much time it will spend, it will decide by itself. Only thing you have to spend time to watch the TV and all these things. Meaning everything is information based. Now I am showing you here some more devices, the smart systems in airport terminal. You'll see here, the one I am showing you here, it is this one, the intelligent parking system robot it is. They are available at the entrance where your car will enter. What is the advantage here? As soon as car will enter, you will log on to this, then barcode your tickets. Then over it is. You no need to search the car parking areas. Automatically robot will drop your car to the wherever the empty space is there. Then as soon as you will enter inside the airport, you are having the intelligent autonomous baggage drop. Your barcode is there here. You will scan your ticket or PNR number. Then it will generate the what we call bag tag. You tie the bag tag, then no problem. You will go directly to the taking your tickets. Meaning ticket also you are taking here. It is a automatic kiosks are there. What we will call intelligent autonomous check-in robot kiosks are there. Once you will take your ticket by you, if foreign, you will use your passport, or here your only PNR. Then what you will do, friends? Directly you will go to the security checkup. Then as soon as you'll go inside the airport also, the intelligent robotic kiosks are there, which will give you the location information, departure timing, departure terminals, cafeterias, many things. Meaning you will see in all the things what is going on, the information processing is going on rather than the conventional material processing. So what it is, design of this product is a concurrent approach rather than the sequential approach. Here we are doing previously, one by one, mechanical engineers will do only mechanical synthesization. Electronic engineers will do electronic synthesization. Computers will do computer synthesization. Now no role for the individual people. All are sit together and make the design and manufacturing of the product. That is the beauty in the mechatronic product. So if you see in the mechatronics, the fusion of various process like a mechanics, electronics, and computing, the design and manufacturing of wide variety of product and processes. You see here, what I am showing you here is the product boundary in which the mechanical engineering, electronic engineering, computing engineering are integrated, which are soft boundaries, meaning they will exchange the data, electromechanical system where electronics and mechanical will integrate, then mechanical and this, all various type of disciplines are added in the domain of mechatronics. At R&D level, if you see friends, 10 disciplines are added in the domain of mechatronics system design. What are those? The motion control, robotics, automatic systems, intelligent control, actuators and sensor, then modeling and design, system integration, manufacturing, micro devices, optoelectronics, and vibrations and noise control. These are all 10 disciplines are embedded in the mechatronic system design approach. What you can call it as a smart manufacturing. Now all converging to this field now. Now, if you'll see this, what is the reason behind it? If you'll see, the mechatronic approach in manufacturing results in cheaper, simpler, more reliable, more flexible, and more information processing part rather than the material parts. Now, if you'll see this, friends, the main reasons for this key change in manufacturing, meaning now we have to integrate more and more sensors in every field, starting with your material handling to and to the customers. To do this, what are the key thing is, as I have told you, the IoT evolution is taking a major role in manufacturing of this product and process. You see, friends, here IoT is happening because of the connected people, connected automotives, connected houses, connected cities, connected industry. All are connected. You no need to do physically. Why these things, how it is happening, why it is happening like this means you see almost all machines and components are cyber physical system. Cyber physical systems are those all are automatic and able to connect to internet. This is required currently. Then availability of inexpensive sensors, mobility is more now, cloud computing is possible now, increased computing power, meaning processor speed and frequency is increasing drastically. I'll show you in the next slide how it is. Then big data and analytics is possible now, meaning you no need to do by hand or by computer. Automatic it is, is the processors are do all the segregation of data. What is required, they will provide you. The availability of secure open platforms are there for designing and implementing the IoT solution. Due to these, all the facilities, now what we are doing, we are moving our conventional manufacturing to the smart manufacturing. As I have told you in the inaugural talk, currently how many devices are there? You'll see, friends, the 9 billion devices are connected to the internet. Each person is connected his 2-3 device, for example, phone, okay, computer and laptop, iTab, tab, all he will connect. Meaning what it is, friends, the number of people on the earth exceeding now. Now people is very less, device connecting to the internet is much more than the people on the earth. This number is expected to 50 billion devices to reaching 1 billion in 2025. Expectation it is. Economic impact is, as I have told you, $2.7 trillion to $6.2 trillion annually by 2025. See the impact of IoT. Now, can you please tell me what is going on? That's why industrial revolution is taking place at a greater pace with this digital transformation. Meaning, you will remember, friends, the dynamic response, smartness, compactness of the systems are due to the lot of development taking place in the VLSI technology, and also the new technology people are using, like artificial intelligence, machine learning, deep learning, data science in the development of intelligent systems, which will do by themselves based on the environmental conditions. So if you see, the key transformation is the availability of powerful processors. And also, as we know that the number of transistors on a chip increases from thousands to billions now. And similarly, the CPU speed increased from kilohertz to megahertz, gigahertz, and now it is a terahertz speed. You will see these will make us to use this digital technology, automate our manufacturing. Just I am showing you here, it is a number of transistor. When 4-bit processor introduced in 1971, how many transistors are there in the small silicon chip? 2250. Now you will see, friends, titanium processor and many more processors are coming. They are having the billions, millions of transistors on the same size chip. And also you will see the speed of the CPU increased from the kilohertz to gigahertz, and still now we are reached to terahertz. Meaning, you no need to worry for data handling and connectivity. Everything is done through the chips. The chip size is very, very small due to the development in the VLSI technology. You will see, friends, the impact. If you will see, there is a tremendous growth in manufacturing industry from standalone machine tool to the flexible manufacturing system. As I have told you, currently the industries are keen to know the Internet of Things in manufacturing, what we call briefly known as Industry 4.0, which means they are flexible, smart, and reconfigurable process in order to address the dynamic global volatile market. Even addressing the single customer is possible in this manufacturing technology. Here, all industries are trying to move towards this technology. But you'll remember, friends, they are also facing the lot of problems. I will tell you in the next slide. You'll see, friends, now here what is going on. Even though their product and processes are different, standardization is different, technology is different in various manufacturing concerns. For example, if you see, just see in automobile industry alone, how many industries are there? Hyundai, Maruti, Nissan, Volkswagen, Ferrari, many more, correct? Products are different, technology is different. And the process industry will see, like oil refineries, chemicals, milk. Even though all this product variety, size, shape, technology is different, all are very much interested to move towards the Industry 4.0 in the design and manufacturing, testing, and they are giving more importance to research on these activities. So the smart factory works mainly on hardware and software integration in really to achieve high speed, more flexible, meaning it is more flexible means how best to use available things to produce best. Then quality, which is a very important aspects in manufacturing. And also some of the important aspects, as our principal told, efficiency and economy is very important, cost of the product. How we are efficient in the existing power resources to produce the products in the global market. We have to think all, meaning how much money expenditure is involved in all these things you have to see. Now I'll show you the very quickly the key features in the smart manufacturing. If you'll see some of the important key features, what we will call it as the all or the cyber physical systems, as we know, correct? Also, cyber physical systems are also known as CPS, or the smart manufacturing objects, SMOs, IoT, big data analytics, cloud computing, man-machine IoT system. Customer is a part in the IIoT system. Some of the future, very quickly, I'll show you the automatic machines. You've seen tremendous change in the machine tool, like a CNC, machining centers, robotics, in all the places in industry, starting with the material handling to the inspection and assembly. Automated material handling, loading and unloading, automated assembly lines, quality stations, automatic storage, cloud computing and storage of huge data, system integration. Here, what we are doing, we are connecting the human to human interaction is taking place, human to machine interaction is taking place, machine to machine interaction, factory to factory interaction, and factory to external world through this IoT based systems. Now, if you see very quickly, some of the views of the people working in industry, this digital manufacturing technology is a journey from static to global market. It is a paradigm shift in business model to see your technology, process, and a physical environment. People will think it is IoT or a IT infrastructure supporting to the manufacturing, cost effective, efficient, sustainable, safe, and creating the new jobs for the white collar jobs. Security and proprietary system it is, collaborating the cyber physical systems and low cost sensors to bring the people, process, and data for better decision in real time process. And some leaders will say it is a networked or a connected enterprise. Some view it is a technology bringing together coalition of people working together with industry, academia on a common platform, building the infrastructure. It is versatile innovation system to manufacturing. Here, connected people who are strong, productive, and faster. Technology making impossible to possible. So get ready, friends, to adapt to this new technology 4.0. Now you may ask question, how to change over to industry 4.0? Now you believe it or not, now still we are in the industry 2.0, maximum extent in automotive industry, we are in the 3.0. 3.0, as I have told you, flexible manufacturing system. Again, here also automated devices, automated machine tool, automated material handling only inside the factory. Now in industry 4.0, all are cyber physical system. Cyber physical systems are one step ahead in the industry 3.0. As I have told you, all are automatic devices like industry 3.0, but here one more capability, all devices are able to connect to the internet for data exchange between the machine to operator, operator to operator, operator to the external world, as I have told you, customers and other industries. This is the one. How to do this, friends? The potential transfer is taking place, calls for the 6 important points here. What I will call interoperability. Meaning what it is? Interoperability, objects, machines, people need to be able to communicate through the Internet of Things and the Internet of People. Visualization, CPC, what we will call cyber physical system, must be able to simulate and create virtual copy of the world, meaning what we will call digital twin technology. Decentralization, the ability of the CPS to work independently, and this gives a room for customized products and problem solving. Real-time capability, meaning a smart factory needs to be able to collect a real-time data, store, analyze, and make these data for the proper decision according to the new findings. Service-oriented and customization. The product must be a customer-oriented. Modularity, meaning it is a dynamic market. Smart factory to be able to adapt to a new market or seasonal changes. That's why it is a modularity. Industry 4.0 is a modular. These 6 points you have to remember when I'm changing over to Industry 4.0. Then if you ask me, various challenges are there here. First and foremost challenge is IT security issues. So as we are told, online integration will give more room to security breaches and data leaks. So the cyber theft must be put away by designing some of the tools. This is one thing. In this, the problem is not an individual, please remember, Fred, but can or probably will cost producers money and might even hurt their reputation. Therefore, the critical research is very essential in IT security issues. Then huge capital is required because I'm converting the conventional machine tool to cyber physical systems. It required the huge money. Sometimes we have to obsolete the old machines. Then employment, meaning what it is, employment means the workers will need to acquire the different or a new set of skills. Otherwise difficult. If you are an old concept, you are operating the lathe machine, drilling machine, milling machine, no jobs. Now you have to learn the new techniques to cope up with the Industry 4.0, connectivity issues, data handling issues. Meaning, you will remember, friends, it will create, on the other hand, the white collar jobs rather than the blue collar jobs. Then privacy issues. Bridging the gap between the consumer and the producer will be a huge challenge, as because in the interconnected industry, producers are not interested to reveal the design and manufacturing aspects to the customers. Customer in turn, even though he wants the product like this, he is not interested to show his data to the manufacturer. Then this is always a problem between the customer and producers in the market. All they want their patent. That is a reason. The small or large companies who haven't shared the data till now, they are having their problems. Everyone, they want to patent to manufacture this product. This is no rooms in the Industry 4.0 because everything should be a transparent system. It is. Now we'll see this very quickly. Some other challenges like a connectivity problems, because we are connecting machine to machine interaction, human to human interaction, human to machine interaction. The connectivity problems nowadays solved due to the 4G communications. Okay, 5G connectivities. Now we are in the 6G and 7G for better performance and connectivity problems to address in industry. This is now this problem is enhanced, but cost comes into the picture. The production system complexity. More and more complex production critical operations will depend on the networking system able to sense, act, and behave within the smart environment. So the importance of managing the configuration, software visioning, and access control will be vital to maintain the quality control and uptime in production. Finding a skilled people is very difficult. Now we need the people who are having the knowledge in the connectivity, network connectivity, artificial intelligence, machine learning, deep learning to solve the IT issues, data handling, 3D printing, programming, all we want now. These type of peoples are difficult to get currently, meaning our thing is updated to these technologies now. Now, if you'll see this, the future status in manufacturing, the AI remains, even though when it is introduced very long back. When AI is introduced, the data we have was not enough to predict the accurate results. But now, friends, we have tremendous amount of data collected through the sensors and things, communications. You believe it or not, now we are working with the ZB. Now the data collection is approximately 44 trillions of GB in the Internet of Things. Then you will see, friends, now we are moving towards the advanced algorithms, high-end computing power, and storage devices, meaning the implementation is now possible due to the development in artificial intelligence, machine learning, and deep learning. Because we are getting the large amount of data, as I have told you, the ZB data, then using your machine learning and deep learning concepts, possible to make the system very effective. But when AI is introduced, the data handling is very less now, which is before 1980s. Later 1980s, machine learning is coming into the picture, which is a subset of artificial intelligence, which will address the large amount of data. Now, after 2010, deep learning is coming into picture, which will address us still better compared to, meaning here what we are doing, and embedding in all the systems like a human intelligence in the agent. Now, quickly, I'll show you very quickly another 10 minutes, the international efforts, plans, and projects around the world. In 2013, Germany launched its Industry 4.0 plan in the name Fourth Industrial Revolution, in which the manufacturing industries are occupied with intelligent machines, products, and all are networked to communicate with each other and with external world autonomously. Germany is focusing research on underlying technologies for manufacturer, such as intelligent real-time sensing, wireless sensor networks, and cyber physical systems. Currently, the Siemens Synalytic, the digital cloud service platform is providing the secure communication, integration of large amount of machine generated data, and its analysis in the cloud, thereby improving the monitoring and optimization capability. Is possible due to this analytics. So under Industry 4.0, the IMS are able to generate the massive amount of data in real time, which help us to take the better decision online. The wake of German Industry 4.0 initiative, the European Union launched Horizon 2020 with nearly 80 billion euros of funding for research from 2014 to 2020. Under the Horizon 2020, the new contractual private-public partnership on factories of the future involved, which will address the green technology, what we will call high performing, environmental friendly, socially sustainable manufacturing. In the United States, in 2012, GE introduced Industry Internet of Things, IIoT. In US, they will call smart manufacturing Industrial Internet of Things. In Germany, Industry 4.0, like this. So in the US, IIoT can be realized with the holistic integration of three major components, like as usual, intelligent equipment, intelligent system, and intelligent decision making. The most prominent organization formed in 2014 is Industrial Internet Consortium, briefly known as IIC, with the support of GE, American Telecom and Telegraph, Cisco, Intel, IBM, with the aim to provide resources to manufacturing industries. So US is predominantly focused on the IT aspects of top layers like a cloud computing, big data, and virtual reality. So currently the GE developed the industry scale analytics, what you can call it as a Predix IIoT, again, which is a cloud-based service software used for huge data collection analysis from industrial machines. It includes again the four core areas: data management, data analysis, cloud applications and mobility, security, and monitoring networked assets. If you see Japan 2015 commenced its industrial value chain initiative known as IVI program in order to connect business via the internet. 30 Japanese companies, including the Mitsubishi, Fujitsu, Nissan Motors, and Panasonic, all are the part in this initiative programs. What for it is? The aim of this is to create the new society by combining the manufacturing and information technologies to create a space in which enterprise can collaborate each other, identify the issues related to manufacturing and connectivities, determine the ideal situation, how human-centric manufacturing will change with the IoT, and puts aside the competitive advantages of individual firms and aims at building mutually connected firms. This is one of the important things taking place in the Japan. If you see in the China, in 2015, China's State Council unveiled a 10 years plan to upgrade its manufacturing capacity to catch up with the production powerhouse such as Germany and US. If the Ministry of Industry and Information Technology, China, created the concept Made in China 2025 initiative, aims to increase its innovative capability in manufacturing, promote a diffusion of information and industrialization, strengthening the basic industrial capacity, boost the Chinese quality branding building, promote environmental friendly manufacturing, enable the breakthrough in key sectors, plus restructuring of the manufacturing industry, plus the advanced service oriented and manufacturing related industries, increase international involvement in manufacturing. So friends, now the future research perspective will see there are the following major research areas where we will focus. The generic framework for intelligent manufacturing calls for the intelligent hierarchical architecture smart grids, data-driven intelligent manufacturing models, intelligent manufacturing systems, IIMs, human machine collaboration, how to enhance, and application of intelligent manufacturing, the new technologies, what we will call the AI, and in manufacturing, what we will call 3D printings, they are playing a major role. This is a framework where we are working from design, machine level, monitoring level, control, and the scheduling. You may ask me how many people are involved in the smart factory? Just see here, as I have told you, all are automatic. According to Warren Bennis, only 2 people, a man and dog. Is exaggerated, meaning man will be there to feed the dogs. Dog will be there to keep the man away from touching the equipment. Exaggerated? Here, what is going on? All the machine tools will run by themselves. Robots will run by themselves. Material handling by run by themselves. Only you have to control through your smartphone. It will changes the blue collar job into white collar jobs. Industrial roadmap, very quickly I will tell you because time is up. Are you ready for the next big wave of industrial revolution? Redesign your manufacturing process. Virtually every product will be transformed into smart product, what we call cyber physical systems. Note friends, they are only playing the major role. Cyber physical systems become Internet of Things. Please note all the new technologies, artificial intelligence, augmented reality, IoT, machine learning, dynamic architecture, horizontal and vertical forming, self-driven, many things are comes under the industry 4.0. This is a roadmap where we have to see in the manufacturing industry, starting with additive manufacturing, cloud computing, okay, touch interfaces, augmenting reality, all are interfaced around the industry 4.0. Learn what, one more thing, very important thing, when you move from conventional to smart, learn what other companies uses industry 4.0, meaning rewards and incentives achieved therein. Find out how many people are required to implement this. Define your industry 4.0 vision and strategic aligned with your business model. Decide and choose what to start. Develop your own industry 4.0 roadmap. Friends, market is highly complex and volatile. These are the very important: product standardization, process standardization, man-machine customer satisfaction standardization. All must be cyber physical system in establishing the interface, layout standardization and flexibility, cyber security, maintenance and redundancy, to build the business ecosystems. Investment and cost structure also take into account when we are converting conventional to smart manufacturing. Quickly, I'll conclude this because I'm having one more lecture. Design approach is always the mechatronic approach in the smart manufacturing. So it is a fusion of various disciplines. As I have told you, 10 disciplines are involved, mainly the mechanical engineering, electronics, and computing. Also note, friends, every component in the smart factory are equipped with the various sensors, like a proprioceptive sensors required for self-maintenance, the internal status, and also monitoring the external world through the exteroceptive sensors. All are connected, communicate with each other, and controlled with each other. Industry 4.0 is a highly complex process, and only you can achieve your product should be cheaper, simpler, more reliable, high quality, more flexible, smart, more information processing rather than material processing. Only when you adapt this is possible. Otherwise, very difficult. Request is to explore how industries can use a digitization to improve the productivity, reduce the manufacturing cost, and improving the data management. There are the 5 dimensions: the smart manufacturing, the product and service capabilities, development, production and delivery, and service value streams. Customer journeys, experience plus value is very essential. Business and operating models, leadership, management and collaboration and learning. think some more areas are left out, what I have told you. For this, no limit, sky is the limit to automate your factory. Thank you for your attention. Then one more thing is for the faculty friends, the new NPTEL course this semester is launching, oil hydraulics and pneumatics. The course link is provided here. Communicate this to your students. Thank you. Then quickly, I will show Shanmugesh,
Yes, sir.
or that other people are waiting there now.
Okay, sir.
Now I will take your questions. Can you please ask them to send through the chat box? I will address after the.
No problem, no problem. I will correct and give
1
it.
minute. Shanmugesh, very fast. Sorry, extremely sorry.
No problem.
1 minute. Now I will share you some videos for you people. Which is how without handling the human handling is very less. How the machine will do automatically by themselves. I'll share you one video. Just you'll see it. Okay. Then I'll move on to one more room. Okay. Sorry.
Okay, sir.
Okay.
Thank you, sir.
1 minute.
Thank you very much, sir.
ಹೇಳಿದೆ ಅವರಿಗೆ 1 second. Just we'll see whether it is visible or not, please. 1 second. Shanmugesh, you see whether
Yes,
it is
sir.
playing. 1 second. Shanmugesh?
Yes, sir. It is clear, sir. FMS.
Yeah, thank you. 3 videos are there to show you some of the things how everything will run by itself. Okay.
Okay, sir. Dev.
Yes, sir. ഒരു 15 minutes ഡിലേ ആയിട്ട് സ്റ്റാർട്ട് ചെയ്യുന്നത് സാർ ഒന്ന് മനസ്സിലാക്കാം. മറ്റേ സ്പീക്കറിനോട് സാർ പറഞ്ഞോളേ
Abba.
ശ്രീരാം.
ഇത് ഇപ്പൊ തീർന്നു. അല്ല, സ്റ്റോപ്പ് ചെയ്യാൻ പറഞ്ഞു.
സാറാണോ പറയുന്നത്?
Sir, can you stop it here, sir? Yeah, the other speaker is waiting. Thank you. Thank you very much, sir. Thank you very much, sir. So hope the first session is being completed. Fill the feedback and we can join in the at 11:15 or 11:20 we can join for the second session. Thank you very much.